Okay, so I guess the sound cut out on my video, so I'm picking it up here on 1991 AB1. And they're saying that we have a line tangent to the graph. Remember that tangent really means derivative. And then we want to figure out where that derivative is horizontal. Horizontal line has a 0 slope. Okay, so then for part A, what we have to do is we have to find the derivative. And we only have the second derivative, so we're going to integrate that second derivative. Okay. And that will give us the first derivative. All right, so if we integrate that, that's going to be 12x squared minus 18x plus c. And that's going to equal f prime. Okay, then from there, we're going to plug in the condition that they gave us for the first derivative, which is that we can plug in 1 for x, which would give me 12 minus 18, right, plus c, and we would be setting that equal to negative 6. So that means that c is going to be 0. So then my derivative is going to be 12x squared minus 18x. Now the question is asking for where that derivative, hold on, right, is equal to 0. And we got this 0 again because a horizontal line has a 0 slope. Okay, slope is derivative. So we're going to take this and we're going to set it equal to 0. And we'll solve for x. So if we set this equal to 0, I'm just going to factor. So I'll take out a 6x, and that's going to give me 2x minus 3. Set that equal to 0, and we would have x equals 0, and x equals 3/2. So there's your two answers. Okay, part B just wants an equation for f. So we are just going to integrate f prime. So we're going to integrate 12x squared minus 18x. And we are going to get 4x cubed minus 9x squared plus c. Okay, then we're going to take the conditions that they gave us right here. And so we'll plug in 2 for x, and we're going to set it equal to 0 so that we can find our c value. Okay, so we are going to plug in 2, right? So that's going to be 8 times 4, which is 32, minus 36, plus c, and we're setting it equal to 0. So we can see that our c is going to be 4. So then our expression for f of x will be 4x cubed minus 9x squared plus 4. All right, part C wants us to find the average value, and we're given this interval, and the average value of f. So we did do this once, but we did it just on one question. So for the AP questions, what we do is an average value insinuates that we should integrate. We have an interval. So now what we have is we have bounds. And that interval would signify what our bounds are. Okay, and then we're integrating f of x. So that would be 4x cubed minus 9x squared plus 4. Okay, the only thing is about average value is it's always going to be divided. Remember when I said if you wanted to figure out the average in a class, you would add up all your test grades and you would divide by however many you have. In this case, we're going to divide by upper bound minus lower bound. Okay? All right. So then what we're going to do is we're just going to integrate 4x cubed minus 9x squared plus 4. So that's going to give me x to the 4th, then minus 3x cubed plus 4x. Okay, now normally we would write plus C. This is going to be the start of what we're doing today. If we have bounds, we're going from a specific place to a specific place. Like, this is really asking for the area under the curve of this graph from 1 to 3. So when we have actual bounds and we integrate, we do not put a plus C. If you go back and you look at all the other questions, the reason why there was a plus C is, if you look, there were no bounds there. Okay, so we're not going to put any bounds, and we're just going to put an evaluation symbol, and we put a 1 here and a 3 here. I'll talk about that in just a second. And then we're going to divide this by 3 minus 1, which is 2. Okay, so what this evaluation symbol means is we're going to plug in the upper bound first, in for x here, here, and here. We're going to work it out. And then we're going to plug in 1 here, here, and here, and we're going to work it out. And then we're going to subtract those answers. So I'll show you. So you're going to plug in 3 to the 4th minus 3 times 3 cubed, then plus 4 times 3. Okay, and then you're going to work that out. Then you'll always subtract upper bound minus lower bound. So now we're going to do 1 to the 4th minus 3 times 1 cubed plus 4 times 1, and you work that out. And then we're going to divide our answer by 2. Okay, so when you work this out, you are going to end up getting, over here you will end up getting 12. Over here you're going to end up getting 2. So we're going to do 12 minus 2, which is 10, and 10 divided by 2, which is 5. So our final answer here then would be 5. Okay, turn the page, and actually 2 pages, and you're going to look at page 29. This is number 4. So we're going to try more with actual bounds now. I would highly suggest that anytime you have a constant, take that out. It's just going to make your calculations a lot easier. So really you just have secant squared theta d theta. So then just keep bringing that 4 down, don't worry about it. And then we're going to take the integral of secant squared, which is tangent. Okay, we don't need a plus c because we do have bounds. All we're going to do is evaluate from the upper bound minus the lower bound. So that's going to give me 4. Then we're going to do the tangent, pi over 4, minus the tangent of 0. Okay, now remember pi over 4 is 45 degrees, and the tangent of 45 degrees is 1, and the tangent of 0 is 0. So your answer is 4. Okay, let's look at number 6. We're going to do the same thing. So if we integrate that, we're going to get x cubed plus x squared minus 5x, no bounds, because, no c because we have bounds. And we're going to evaluate this from -1 up to 2. Okay, so we always put the upper bound in first. So we're going to do 2 cubed plus 2 squared minus 5 times 2. Let's make that a brackety thing so we don't get confused. Okay, minus, now let's plug in -1. Cube it, -1. Square it, minus 5 times -1. Okay, so on the left here, we're going to get 8 plus 4 minus 10, okay, which is 2, minus, and then we're going to get -1 plus 1 plus 5, which is 5. So the answer is -3. All right, I chose this one just because look at the fraction. Need I say more? So I would make this 1 over radical x plus x over radical x. Oops, and let's keep that from 1 to 4. All right, I still think that's ugly. Let me bring this down here. So then I would keep this from 1 to 4, and 1 over radical x is really x to the negative 1/2, plus, and then this guy right here is really x times x to the negative 1/2 power. So remember, when you have the same base, you add the exponents. So that's going to be x to the 1/2. Okay? All right, so let's go ahead and integrate that. So that's going to be x to the positive 1/2. But remember, we're technically dividing by 1/2 or multiplying by 2. This one's going to be x to the 3/2. So we're technically dividing by 3/2 or multiplying by 2/3. Now, no plus c because we have bounds. So we're just going to evaluate that from 1 to 4. Okay, so we're going to do 2 times 4 to the 1/2 plus 2/3 times 4 to the 3/2, then minus, and now let's plug in the 1. So 2 times 1 to the 1/2 plus 2/3 times 1 to the 3/2. Okay. So this is really just going to be 2 times 2, because 4 to the 1/2 power is really radical 4, plus 2/3. All right, let's talk about this for a second. This is power over root. So we're taking the square root of 4, which is 2, and then that 2 cubed is 8. Okay, so that's times 8 minus, then 1 to the 1/2 is obviously just 1. That right, square root of 1 is 1, so this is just going to be 2. And then we're going to do essentially the same thing over here. It's power over root. So we're taking the square root of 1, which is 1, and 1 cubed, which is 1. So that's just going to be 2/3. Okay. Now I see that I've got denominators of 3, so I'm going to put all of these in the form of a fraction with a denominator of 3. So this is going to be 12 over 3, right, because that's 4. This is going to be 16 over 3. Okay, minus, and then 2 in terms of 3 will be 6/3, and this would be 2/3. So that's going to be 28/3 minus 8/3, which is 20/3. And that would be your answer. Okay, and 20/3 is choice A. All right, sorry about the video. So we should be all good now.